All right, hello there. In this video, I'm going to teach you how to implement while loops in YASM x86-64 assembly, although you probably don't need to be using YASM assembly to understand this video or to benefit from it. So what am I talking about? First off, okay, so we're going to do while loops. There's a lot of assumed knowledge in this video. If you don't know how to make a basic YASM assembly program, if you don't know how to make a makefile, if you don't know a lot of the basics that I'm just skimming over in this video, you'll need to see my other videos because I explain all of those things at length. For this video, I'm just going to be talking about while loops only. So for starters, let's see here. I'm going to open up a little notepad here and just type a while loop and try to explain a little bit about it conceptually. And then after that, we're gonna write a program in YASM to show that we can get this to work. So what is a while loop in a higher level language? We'll just suppose C or C++. You can imagine whatever language you want, but typically in a while loop, we're not talking about a do while loop, although that would be really easy to implement after watching this video. But in a regular while loop, you have the keyword while usually, and then you have some sort of an expression like does A equal B or whatever. So maybe I'll just say does A equal B? And as long as that expression evaluates to true, then the body of the while loop will execute. And then when it's done executing, execution will go back up to look at the expression again and make sure that it's still true. So the loop will run forever until that expression evaluates to false. Maybe that's what you want, maybe that's not what you want, but that's what it'll do. And that means the body runs an endless number of times. Also, if the expression evaluates to false on the very first run, then the body of the while loop will just never run at all. So that's, a basic idea of a while loop in a higher level language. Hopefully you kind of already know that. So let's look at the parts right here. If we imagine this as assembly, then probably the first thing we should do is label the part where we look at the expression and decide whether we're going to continue or not, right? So I'm going to put a little label here, and maybe we'll call it while top or something. Whatever you want to do, just to label the part of the code so that we know when we write assembly, we'll be able to put the appropriate labels on the different parts of the while loop, and we'll be able to imagine the while loop that we're implementing in assembly. So I'm going to say this is the top, or you can call it the eval part, whatever you want. Then we'll make another label down here. We'll call it, while body, something like that. And so basically, if we want to jump up to the top of the while loop to evaluate the expression, we just have to basically jump to that label called while top. And if we want to jump to the body to actually execute the code, then we just have to jump to that other label instead. We should also have a label at the very bottom after the whole while loop is over, and we'll call it, while finished, or while, finished, or while done, or while over, something like that. So I'm just going to put while done. And then now you can imagine that when we're at the top of the while loop and we see that the expression is false, then we can just jump down to the done label, thereby, exiting the entire while loop. Then, of course, we probably want to have some jump statements in here. So, for example, the expression part here, it's probably going to jump either to the body or either to the done area based on whether or not the expression evaluated to true or false. So maybe I'll put label while top, which contains a conditional branch and then like an unconditional jump. So if a condition is true, maybe we can jump into the body. If the condition is false, we'll fall through to the next statement and do an unconditional jump to the done label. If you don't know conditional branching, this is another one of the topics that I've covered in previous videos. We're just going to skim over conditional branching as we implement the while loop. So just keep in mind, there are other videos that I have that you should watch first if you don't understand conditional branching or jumps. The reason that I'm going to kind of design the jumps like this, where I'm going to say, let's do a conditional branch, and basically if the loop evaluates to true, we'll jump into the body of the loop. And if it doesn't evaluate to true, then the conditional branch will allow execution to fall through down to the next statement, which will simply contain a jump to the done portion. So basically, as soon as the while loop is ready to break, it gets implemented by an unconditional jump, which was fallen through to by the conditional branch that would only jump into the body if expression was true. I'm doing it this way because it's usually a shorter jump to jump to the true area, the the body of the while loop. And remember, conditional branching instructions have a maximum, jump reach of about 128 bytes. So if you try to jump too far, like for example, if you wanted to, you could reverse the logic to where you could say, if an expression is true, let's jump to the done portion and say we're going to break the loop. If the expression was false, we'll jump into the body. You could do that, but then if the body of your while loop was too long, maybe it was so long that the last instruction was greater than 128 bytes away from the top, then by the time you wanted to, let's see. Yeah, if you have too long of while loops, you can't jump more than 128 instructions away. So that's a limitation of conditional branching. So I want to put the biggest jump on an unconditional jump instruction because it doesn't have a limitation like that. I was having a hard time imagining what I was about to say just now for the reversal. I guess I'm just going to ignore the reversal scenario and we'll just do it the regular way. Anyway, so we want to have a conditional jump that either jumps into the body or to the done area. And then at the very bottom, we want to have an unconditional jump to the top, which basically means every time we get to the bottom of the while loop body, we're just going to jump up to the while top. Actually, I'll just say to while top. Remember, again, the regular jump instructions, maybe I'll take out the U here. The regular jump instructions don't have a limitation on how far they can jump, so that should be fine. And that's the basic idea of implementing a while loop. Maybe I should draw out just a quick diagram before we start looking at the code, just to make sure everybody of different learning styles understands what I'm talking about. So we'll, let's see, eval. I'm still adjusting my pen, and you know what? It looked a lot better before I hit record. Eval the expression. So I'm going to first evaluate the expression. If it evaluates to true, we'll put a green arrow here, and I'll put like a T for true. Then this will be the body of the while loop. I'll say like the body. If it evaluates to false, let's see. Evaluates to false, maybe I'll just put that in red and I'll put an F here. Then this is just going to be the done area. Right, so you can imagine we evaluate an expression using the compare instruction in assembly, and based on the results of comparing something, whatever it is that your condition is, then we we either branch to the done area or we branch to the body area. And if you want to have a more complicated while loop and you don't want to put a huge amount of expressions, or if you don't want to logically concatenate a bunch of different components into the expression, that's fair. I usually write my while loops in real life as just while true, and then I break when certain conditions are met. You can do that too. We're not going to talk about that in this video, but you could just have a while true, so you always jump to the top, and there's no branching that goes to while done. But then throughout the loop, you can just sort of check to see if certain conditions are met, and if they are, then you'll do a branch to the done area, and if they're not, then by the time you make it down to the bottom of the loop, then it just automatically jumps to the top. Although you got to make sure with the reach of conditional branching, you probably want to test to see if your condition is true or false or whatever. If it means we're going to continue the loop, then you probably just want to do a conditional branch that jumps down a little bit so that it can continue the body of the loop. And then the part that it skipped over, just a little part, should be an unconditional jump that jumps out of the loop. That way, it doesn't matter how big your while loop body is, you can always jump out of the loop. But we're not going to talk about that in this video. Anyway, so we evaluate the expression. If it's true, we go to the body. If it's false, we go to done. After the body is done executing, then we just jump back up to the top where we evaluate the expression. I'll put while here just to make it more clear that we're talking about the basic idea of a while loop. Not too hard, and then if you wanted to implement a do while loop, just make sure that you always evaluate the body at least once. That's really the only difference. But that's up to you. This is just a regular while loop video. Okay, so we've kind of talked about it a little bit. We've sort of, drawn it out in a diagram and put some regular code in. Let's set up an actual assembly program that will do this. So for starters, again, I'm not going to show you my makefile because I've already made other videos where I explained how to make a makefile from scratch. Same thing goes for hybrid programs. I'm going to have a driver, which is a C++ module that just sort of calls on this assembly module. If you want to know how to make hybrid programs or, drivers or, whatever, see my other videos. For now, I'm just going to be talking about looping only. Okay, so let me get my solution up here. My source code is called looper, and I'm just going to copy paste the data section from my program real fast, just so you can see it. Okay, so here's the data section. Again, this is not a basics for assembly video. If you don't know how to do a data section in YASM, see my other videos. But for now, I'm just going to say I'm making some C strings, and each C string just has like the actual array of bytes and then a length. And all I'm doing is printing out messages, begin the while test. Your numbers will be printed back to you until you decide to quit. So that's going to be printed to the user right away. Then every time the program wants a number from the user, it'll just ask, please enter a number or 99 to quit. And then it'll prefix the echo back. It'll say you entered, and then it will actually print the number. And then when you eventually enter 99, it's just going to say we're done. And I'm going to use an external function that I have available to just kind of like input and output numbers. This video is not about input and outputting and external libraries. If you're interested, you could probably just link a hybrid program and use printf and scanf to very easily do input and output. But that's not what this video is about. See my other videos. Then I have CRLF, which is just a carriage return in line feed, so like the cursor goes to the next line. And then I have like a system call code to just print, and then a file descriptor just to print a standard output. Again, that's explained in other videos. So now I'm ready to start copy pasting the main portion of my program. So first off, I'm going to start the text section, which is where the instructions go in YASM. So there it is. And then I'm going to copy paste my designation of external symbols. So I just have a little library that I'm using that makes it easier for me to input and output integers. So you can do this any way you want, or you can hard code a number in the globals area if you don't want to deal with input and output while you're learning how to do loops. That's totally fine. But then the entry point is going to be a function called looper. So this is my function. And again, this is a hybrid program, so the main function or the underscore start function is not going to be present in my assembly module. The driver is going to be a C++ module that just calls on a function named looper. So that means this function is going to get called from another module, and that's why I have to mark it as global. And then it is a function, so I'm going to call return at the end of it to say we're done. And then within this function, I'm just going to call two other functions that I'm about to create. One is called while test, which is going to actually do the while loop. And the other is called CRLF, which just prints a new line for me. I don't know why I do it that way, but I want to. Sorry, not sorry. So this is the real meat of the function here. Let's start, the real meat of the code or the video. Let's start a function called while test. You can see it's got a void signature with no argument, so it doesn't really, take anything or return anything. I'm gonna use register R12 to hold the user's input so that I can, print it out and stuff. So that means I have to do a preservation of R12 because it's callee saved per the ABI, which you should respect. So I'm gonna push it at the beginning, and then I'm gonna pop it at the end, and then this is a function, so I have to return at the end of the function. Let me just double check that there's nothing else weird at the bottom of that. Nope, okay. So we've got the Prologue and Epilogue. The while test function is being called. Maybe I should copy paste my CRLF real fast. My CRLF function, it's just sad, but it's also kind of cute, right? It does nothing except just print out a new line. That's all it does. This video is not about that. So at this point, I should have a program that probably works. Let's see if it does. I'm going to do clear and make run. Again, if you want to know how to use makefiles or compile or link or anything like that, see my other videos. So I'm going to run it, and it just says hello from the driver, which is some code that we're not looking at, and then it says it's regained control. And this line in the middle, which is just an empty new line, that's definitely from the assembly program, because at the top here we have CRLF. If I call it multiple times, CRLF, then you'll see there are multiple blank lines. All right, I'm going to take that out. Now let's continue with while test. So what should we do here? The first thing that we should do is print an intro message, just to let the user know that we're about to begin our while test. And if we run the program one more time, we should see that message now. Begin the while test. Your numbers will be printed back to you. System calls and simple printing is covered in other videos. So now, for me, I kind of like to init all of my loops, even if it's a while loop and not just a for loop or anything. So I always have an extra label that I like to call init or before or something like that. So I have a label now called while test underscore init, and it's just where I'm going to initialize whatever it is that I think I need to initialize so that the loop will actually work. If you look here, all I'm really doing is setting R12 to 0, because what I'm going to do is stop the loop. I'm going to break the loop whenever the user enters a 99. So I don't know what's inside of R12 when we first start this function, and I just want to make sure that it's not 99, the stopping number at the very start. So I'm just going to set it to 0. So another note about my labels, you don't have to do it this way, but I love to write labels where the first part of the label is always the function that the label is inside of. So notice how the function is named while test, and so my label is always while test underscore something. And I'm putting a init here just to say we're initializing the loop, but if you had a function that had a lot of stuff going on in it, for starters, you should probably be breaking up that function into multiple functions. But assuming you didn't, you should probably do another underscore and then like another component and then another underscore based on what giant chunk of your function you're inside of. So if there was like an if part, a while part, an input part, an output part, you probably want to stick that into your labels. Your labels will get huge, but for me personally, it's really easy to get confused in assembly, and this makes it easier. So we're going to initialize so that we can run our while loop, and then the next thing we're going to do is implement the top of the while loop. So remember, if we looked at this code up here, maybe if I drag this over to the side and pin it to the top for a little while, you can see that the top of the while loop is where we kind of evaluate the expression to see if we need to keep going or not. And then we'll either jump into the body or we will jump into the ending area, the done area. So the top, the top is always for that. We'll say, first I'm going to ask, are we done? So, how do we know if we're done? In this particular while loop, we want to compare the user's input, which is R12, to the number 99. And if it's equal, then we will quit, which means also if it's not equal, we will jump into the loop's body. If it's not equal, then we continue looping. So, by the way, you're probably wondering, how did R12 get the user's input? Well, we're going to do that as the next step. And of course, your design pattern may vary a little bit. That's okay. I just like to implement it this way. So first thing we're going to do is compare R12 with 99, and that's why I've written this comment here, just like the blank while comparison part. And I guess I could have put this R12 not equal to 99 up at the top, but then it kind of feels like I'm leaving out these other two instructions, so I moved it down one. So basically, as long as we compare R12 and 99, compare and conditional branching is covered in other videos, but we compare those two values, and then we say, if R12 is not equal to 99, then jump to the body. And we expect that the body will be like a short jump, which will be within the range of a conditional branch. So anyway, if the not equal branch didn't happen, that means R12 is equal to 99. At that point, execution falls through to line 84, and we'll just unconditionally jump out of the while loop. So basically we're saying, if it's true, we continue looping. If it's not true, we just jump outside of the loop. We're just totally done with the while loop. Okay, so then we need a body, because obviously we're going to jump into the body here. So that means I'm going to just copy paste another little set of code here. Like right after that unconditional jump. So now we got the body. Notice how I put a little comment here that has a brace just to indicate to you, hey, this is the beginning of the actual while loop body, just to make it a little bit more clear. And what are we going to do inside of the body? We're just going to ask the user for some input. So I'm printing a simple message here, and then I'm calling on my helper function to just actually input a number from the user. I'm going to store that number into R12. So that's how R12 gets the numbers, gets the user's input. And the way I've written this, if the user enters a 99, it'll echo it back to the user, and then it'll break the loop afterwards. So, you know, if you wanted to rearrange things like I talked about before, where you input before you check to see if you're going to keep going, you could do that, but it would be a little harder to echo the user's input back to them before you break. I don't know, it's up to you. Anyway, so we grab input from the user, and then we print another message basically saying, here's the thing that you inputted, no problem. And then again, we use one of my helper functions to actually spit the number back out at them. So this is not a very complicated body. It's just asking for a number and then printing the number back to them. And then after that, I'm going to do another label, and I'm going to call it the body bottom. We don't really have to do this label, but for clarity, I think it's probably a good idea. So the very bottom of the while loop's body is usually where you don't do any more instructions that are part of the work of the while loop's body, but just sort of the place where you jump back up to the top so you can evaluate and decide to continue or not again. So notice how I'm using an unconditional jump here. That's a good idea because, again, if you have like a huge while loop body, you might end up surpassing the threshold of 128 bytes, and then you'll get an assembler error that says, I can never remember this. It's like jump out of range error or something like that. Basically, if you do a conditional branch to jump up at the top, because some people like to check to see if they should continue the loop, they like to check for that at the bottom. I've done that before. And then if true, then we'll jump to the top of the loop. But if the loop is too big, that won't work. So I just like to take a long jump to the top of the loop and then decide if I'm going to keep going at the very top. And then there's a comment saying, hey, that's the end of the body. Okay, no problem. Now, let's do the done label, which is basically where we jump if the loop is actually finished. So remember, if this expression right here evaluates to false, then execution is going to fall through to line 84, where we jump to this while test done label. And so I'm just going to put the while test done label right here. So we're done. So the done is not part of the loop. It comes after the loop. That's this right here on line 9 of the little notepad. And we can just kind of do whatever we want at that point. We can return to a caller. We can just do other stuff. We can, you know, do a different loop or, you know, whatever. We're just done with the original loop. For me, I'm just going to say goodbye with this little print to just sort of like, you know, print an exit message. And then we'll do the epilogue where we restore R12, and then we just return to the caller. Let the driver worry about exiting the program. Okay, so if we've done this correctly, we should now have a working program. Let's see. Let's see. Okay, let's enter a number. Let's do 22. And it says you enter 22, and let's do 55. And we can enter any numbers we want. And as long as we're not entering 99, the program will just continue forever. So this is a while loop. If I want to quit, I do 99. And it says you entered 99, and then it breaks at the top. It breaks by jumping down to the done area, where we print our goodbye message, which just is end while test. And then if we run this again, if I do 99 from the start, then it just immediately breaks. You know, it prints out what you entered, but then it immediately breaks. And that's it. That's the basics for how to write a while loop. You just use basically conditional branching layered on top of an abstract concept of what you think a while loop is, or what I guess the world thinks a while loop is. Okay, thank you so much for watching this video. I hope you learned a little bit of stuff and had a little bit of fun. I'll see you in the next video. Hey everybody. Thanks for watching this video again. From the bottom of my heart, I really appreciate it. I do hope you did learn something and have some fun. If you could do me a small little favor, could you please subscribe and follow this channel or these videos or whatever it is you do on the current social media website that you're looking at right now. It would really mean the world to me, and it'll help make more videos and grow this community. So we'll be able to do more videos, longer videos, better videos, or just I'll be able to keep making videos in general. So please do me a kindness and subscribe. You know, sometimes I'm sleeping in the middle of the night and I just wake up because I know somebody subscribed or followed. It just wakes me up and I get filled with joy. That's exactly what happens every single time. So you could do it as a nice favor to me, or you could troll me if you want to just wake me up in the middle of the night. Just subscribe, and then I'll just wake up. I promise that's what will happen. Also, if you look at the middle of the screen right now, you should see a QR code which you can scan in order to go to the website, which I think is also named somewhere at the bottom of this video. and it'll take you to my main website where you can just kind of like see all the videos I published and the services and tutorials and things that I offer and all that good stuff. And if you have a suggestion for clarifications or errata or just future videos that you want to see, please leave a comment. Or if you just want to say, hey, what's up? What's going on? You know, just send me a comment, whatever. I also wake up for those in the middle of the night. I wake up in a cold sweat and I'm like, it would really mean the world to me. I would really appreciate it. So again, thank you so much for watching this video, and enjoy the cool music as I fade into the darkness, which is coming for us all.